In the darkness before time, the first light should have been chaos. Yet when the James Webb telescope looked back, it saw cities of stars too early, too perfect, too vast. Something is wrong with our story of the universe, and it's rewriting everything. Asterisk in the cold silence beyond the moon. A machine made of gold and glass unfurls like a flower opening to the void. Each petal a mirror, polished to perfection, aligned to catch the faintest whispers of ancient light. Its name is the James Webb Space Telescope. Its destination, the second Lagrange point. A gravitational oasis a million miles from home, where sunlight and shadow find balance. There, in eternal darkness, it waits, staring into forever. For 30 years, humanity dreamed of this moment. A dream born in the trembling pixels of another machine, the Hubble Space Telescope. When Hubble first opened its eyes in 1990, it saw not clarity, but confusion, blurred, distorted. A mirror's flaw that almost broke our faith in the stars. And yet, after correction, Hubble revealed the unimaginable. Galaxies scattered like embers across the void, stretching back billions of years. Each one a time capsule, a cosmic memory. But even Hubble had limits. Its eyes were tuned to visible light, the light of the present. To see the true beginning, humanity needed to see the light that had aged, the light stretched thin by time itself, the invisible glow of the infrared. So they built a telescope that could see not just farther, but deeper past the veil of creation. It was a feat that nearly broke the boundaries of engineering. 10,000 scientists, 17 nations, and 3 decades of perilous design. A mirror the size of a house. A sunshield as thin as a razor and as wide as a tennis court. Every part had to fold, to fit, to survive the violence of launch, then unfold itself flawlessly in the frozen emptiness of space. One misfired bolt, one jammed latch, and 30 years of human hope would scatter into silence. When it finally reached orbit, humanity held its breath. The first unfurling, the first alignment, the first light test, it all worked. The universe, for once, did not flinch. And then, in July of 2022, the world waited as the first image was revealed. SMHS 0723. The first deep field of James Webb, a patch of sky no larger than a grain of sand held at arm's length. It looked empty, but through Webb's eyes, it was alive, an ocean of galaxies, each one glowing from a time before the Earth had even dreamed of forming. Some of that light had traveled for over 13 billion years to reach us, and in it, scientists expected to see chaos. The universe, so young, should have been filled with rough, infant structures, small, dim, turbulent knots of gas. But what they saw instead was order. There, shimmering in Webb's deep gaze, were mature galaxies, spirals, ellipses, rotating, massive, elegant. Galaxies that should not exist so soon after the Big Bang. They were ancient by structure, yet impossibly young by time. It was like opening a baby photo and finding the face of an adult staring back. Light, born when the universe was barely 300 million years old, carried the fingerprints of civilization, cosmic architecture. Every law of cosmology said it was impossible. And yet, there it was, captured in golden mirrors, in the control rooms of NASA and ESA. Silence fell. Scientists leaned closer to the monitors, to the data streams, as if proximity could make sense of what they saw. Spectra confirmed their age. These galaxies were not illusions, not tricks of gravitational lensing, not errors in calibration. The numbers were relentless. They existed at a time when physics itself said they could not. The birth of galaxies was supposed to be gradual, slow assembly of stars over billions of years. But the Webb images painted another story, a universe that built too fast, too bright, too soon. Every photon Webb captured was a messenger, an echo from the beginning. It carried the scars of time, stretched into the red, its energy weakened but never gone. Those photons had been traveling since before there were planets, before there were atoms of iron or carbon in our blood. Each one struck Webb's mirrors like a heartbeat from the cosmos, whispering secrets we were not prepared to hear. Secrets about time, about creation, about the speed with which the universe learned to dream. Astronomers recalibrated, recalculated, rechecked every step. Was the redshift wrong? Could these galaxies be closer than they seemed? The answer came, cold and clear, no. Their light was genuine. Their distance was real. The universe had matured in an instant. Something, somewhere, was missing in our equations. The voice of science trembled not in fear, but in awe. For centuries, humanity had looked to the heavens, seeking confirmation of its models, the comfort of predictability. Now, the heavens looked back with indifference, as if to say, "You have misunderstood me." It was not chaos Webb had revealed, it was complexity, impossibly early. Galaxies heavy with elements like oxygen, carbon, neon. Metals that could only exist after generations of stars had lived, burned, and died. And yet here they were, present in the dawn, as if the universe had skipped its own childhood. In the silence of space, the telescope drifted on, collecting light older than memory. Each new image deepened the wound in our understanding. The cosmos was not what we thought it was. It was faster, denser, more efficient at creation than our laws allowed. And beneath the scientific tension, something else stirred wonder. A wonder tinged with fear. Because if time could bend this way, if galaxies could bloom before they should, then what else had the universe hidden in its first moments? Back on Earth, the data poured in like a flood. Spectrographs and simulations clashed in digital storms. Theories fractured and reformed overnight. Papers published, then retracted, then published again. What Webb had seen was not just a discovery, it was a betrayal. A betrayal of our most trusted story, the story of beginnings. And yet, within that betrayal, there was beauty. Because only by being wrong could humanity grow closer to truth. Somewhere, deep within the machinery of that golden eye, the faint hum of human ambition echoed a vibration that had crossed generations. From the dreams of Galileo to the equations of Einstein, to the engineers who risked everything for one perfect image. They built a machine to look backward in time, and it found the impossible in that moment. A quiet realization dawned across every screen, every observatory, every mind reaching for understanding. Perhaps the universe did not begin slowly, like a sunrise. Perhaps it erupted all at once, an artist painting galaxies before the canvas had dried. Or perhaps time itself is not what it seems. Maybe the early universe was not young at all, only closer. Maybe what Webb saw was not the beginning, but an echo of something far older, folded through dimensions we cannot yet see. The telescope kept its vigil, orbiting the invisible point between sunlight and shadow. Its mirrors, gold against black, reflected a universe that refused to explain itself. For the first time, humanity's greatest eye was not showing answers, was showing contradictions. And somewhere, between those contradictions, between the light and the silence. A question hung heavier than any discovery ever made. If these galaxies truly existed so early, then the universe learned to build too fast, or time itself has lied to us. The shock came not as thunder, but as silence. A silence so complete that even the hum of the servers seemed hesitant, as though the universe itself was holding its breath. On screens across NASA, ESA, and distant observatories scattered over the Earth, the same data appeared: numbers, spectra, redshifts so large they bordered on the absurd. For a moment, no one spoke. Then, like a ripple through still water, disbelief began its long echo. The universe, according to every model humanity had built, was supposed to grow with restraint. The CDM model Ameda, cold, dark matter, our best and most sacred cosmological script, told a story of gentle progression. From the Big Bang's seething chaos, the first atoms formed after 380,000 years. Gravity gathered them into the first stars after a few 100 million. Small galaxies came next to clumps of gas and dust, fragile and faint, gradually merging into spirals and giants across billions of years. It was a universe that took its time, building slowly, patiently, predictably. But the James Webb telescope had seen something else, something that refused patience. In the faint light from the edge of time, galaxies appeared that should have taken billions of years to exist fully formed, bright, structured. Galaxies not 10 million times the mass of our Sun, but 100 billion, compact, brilliant, ancient. Their light, stretched by time, whispered a single heresy. The universe was too mature, too soon. At first the data was doubted. Emma Curtis-Lake, one of the lead scientists on the JADE survey, stared at the spectra that no longer fit into known history. Rohan Naidu cross-checked the calibration. Brant Robertson questioned the modeling pipeline, searching for contamination, instrument noise, a misread pixel, anything that could explain away the impossible. Teams across the world mirrored the same ritual. The first instinct of science is not belief, it is skepticism. They doubted themselves before they dared to doubt the cosmos. Could these be brown dwarfs mistaken for galaxies? Could gravitational lensing, the magnification of distant light by intervening clusters, be playing tricks on their instruments? Could Webb's ultra-sensitive sensors be reading phantoms, ghost images, mirages born from cosmic dust and human hope? For days, the questions circled the world like invisible satellites, but the data remained relentless. Spectral lines, the fingerprints of hydrogen, oxygen, carbon, did not lie. Each element carries its own barcode in light, and those lines were stretched by redshifts of 10, 12, even 13. These were no illusions. They came from a universe only 300 million years old. They were older than galaxies had any right to be. A strange unease settled over the scientific community. It wasn't simply that the data was surprising, it was that it threatened the foundations of cosmology itself. If these galaxies existed, then the models that define dark matter, structure formation, and cosmic expansion were incomplete or wrong. The CDM model had predicted a universe that evolves slowly, governed by invisible dark matter scaffolds pulling gas together. But Webb's findings hinted at another story, a universe that builds with ferocity, a cosmos that races toward complexity like a fire seeking fuel. At conferences, debates turned heated. In journal papers and quiet corridors, arguments raged over methods, over meaning. Was the telescope overestimating brightness? Were these early galaxies truly massive, or merely compact and efficient? Some argued the stars within them must be different, larger, hotter, living fast and dying young, producing light far beyond what modern stars could. Others whispered that perhaps dark matter behaves differently in the early universe, or that dark energy, the mysterious force driving cosmic acceleration, was stronger then, compressing time itself. But beneath the speculation was something more primal. Or, the last time science had felt this kind of dissonance was centuries ago, when Copernicus dared to move the Earth from the center of the cosmos, when Einstein bent the straight lines of Newton's universe into curves of spacetime, when Hubble looked through his telescope and discovered the galaxies were fleeing from one another, proving the universe was expanding. Now, once again, the heavens had whispered a truth that fractured understanding. In that sense, Webb was not an instrument of observation, it was an instrument of revolution across the data archives. The galaxies were catalogued with sterile names: JHG SC130, GLAS SC12, CEERS 93316, but behind each cold designation pulsed the same cosmic paradox. How can something so ancient exist so early? Every number was a defiance, every image a rebellion against the comfort of theory. If the universe could create this much structure in so little time, what else might it be hiding from us? In Cambridge, Harvard, Tokyo, and Cape Town, sleepless eyes watched the graphs unfold. Simulations were rerun, cosmological parameters adjusted. Each time, the models failed. The early universe simply did not have enough matter, enough time, enough physics to build galaxies like these. The math resisted, but the light persisted. Reality had chosen its truth. Emma Curtis Lake described the moment in quiet disbelief. It's not that the data is wrong. It's that our expectations were in a single statement. She spoke the unspoken creed of scientific humility, the willingness to admit that the universe has no obligation to make sense. Within that humility, wonder bloomed again. Because what is science, if not a love affair with mystery? Each contradiction, each paradox, is a gift, a chance to rebuild our understanding of existence. Yet even in wonder, fear lingers. For if the cosmic dawn unfolded faster than time allows, then perhaps the story of the Big Bang itself is missing chapters. Perhaps the beginning was not smooth and steady, but violent and accelerated, something beyond inflation, beyond current equations. Or perhaps time itself, as understood by relativity, breaks down near the origin, flowing in ways we cannot yet measure. Maybe the first galaxies are fossils from another epoch, from cycles of creation that preceded our own. In every corner of astrophysics, speculation turned to awe to obsession. The telescope had become both oracle and trickster, its golden mirrors, reflecting a cosmos that lied in beauty, outside the halls of science. The public marveled at the images, unaware of the existential storm beneath the surface. To the world, these were simply beautiful pictures, glittering jewels of the early cosmos. But to those who knew, each image was a question burning through equations, an open wound in the heart of cosmology. Every discovery Webb made seemed to deepen the rift between theory and truth. What does one do when the universe refuses to follow its own laws? When the first light of creation looks back with the knowing eyes of age? The answer is both simple and eternal. Look again. That is what scientists do when the sky betrays them. They rebuild their questions. They let the unknown become the engine of progress. In the end, the disbelief softened into a strange acceptance. The universe had always been stranger than its observers. And Webb, with its gold mirrors and its quiet courage, had merely reminded humanity of that fact. It had seen farther than any eye before it. But more importantly, it had seen deeper. Through the illusions of certainty, above the earth, it continues to stare into infinity. Its instruments drinking in the glow of ancient galaxies, each photon a contradiction, each image a quiet defiance. The universe had kept a secret for 13 billion years, and when James Webb finally uncovered it, the secret was not chaos or emptiness. It was complexity beyond time. Webb did not just see further, it saw earlier than physics allowed. The investigation began as all revolutions in science do, not with certainty, but with doubt. In the weeks after Webb's first deep fields shattered the known order, the world's observatories came alive. Screens flickered in Harvard's astrophysics labs. Cables hummed in Caltech's data centers. At the European Space Agency's mission control, night and day blurred into one continuous vigilance. And across the oceans, from Kyoto to Cape Town, telescopes on mountaintops turned their mirrors toward the same invisible past, chasing the same ghostly light. The question was simple, almost naive. Could the telescope be wrong? The scientists who asked it did not doubt lightly. They had built their lives upon skepticism, the discipline of disbelief. So they probed the Webb data with the precision of surgeons. The Sears survey, the JADES program, the GLASS collaboration, each reanalyzed, recalibrated, and cross-examined the spectra pouring down from the cold silence of L2. They fed the numbers into new algorithms, cross-matched the redshifts, mapped the faint smudges of ancient light with supercomputer simulations. But no matter how they turned the image, the shape of the paradox remained. The light was too old, too strong, too structured. Every analysis told the same story. The early universe was crowded with mature galaxies, glowing like embers in the aftermath of an impossible dawn. Webb's instruments had not erred. Its INACAM, the near-infrared camera, was built to see beyond the visible, to capture the stretched whispers of ancient starlight, redshifted by the cosmic expansion. Each pixel of its golden mirrors gathered light that had traveled for more than 13 billion years. Light so faint it arrived as single photons, and its sibling, UNIARSPEC, the near-infrared spectrograph, took those photons apart, separating them into spectra, decoding their elemental fingerprints. Hydrogen, helium, oxygen, carbon, the language of creation written in color. Together, IACAM and IASPEC reached past the horizon of human history and into the first billion years after the Big Bang. An epoch no eye had ever seen that what they found there defied the story of gradual cosmic birth. Galaxy G UNZI 11, once thought to be the oldest known, discovered by Hubble years before, had already been a marvel. Now Webb found its ancestors, even older and brighter. JADES G SC 1320, a galaxy that lived when the universe was a mere 330 million years old. Others soon followed. GLAS SC 12, CEERS 93316, each a silent witness to an age of accelerated creation. These were not chaotic clouds of gas. They were structured systems, burning with intensity, heavy with stars that should not yet have existed. The numbers were no longer anomalies. They were a chorus. A pattern was forming, and it was unmistakable. Galaxies were forming far earlier and more efficiently than physics had ever predicted. Cosmic dawn was not a dim flicker in the void, it was a sudden blaze. The universe had built cities of light before it had even learned to crawl. And then came the deeper shock. Within the spectra of these galaxies lay the unmistakable traces of metals, elements heavier than hydrogen or helium. In cosmic terms, metals are the fingerprints of ancestry. They can only exist after generations of stars have lived and died, forging heavier atoms in their fiery cores, scattering them through space when they collapse into supernova. Yet here they were, gleaming in the light of galaxies from an epoch barely out of infancy, oxygen, carbon, neon, elements that should have required hundreds of millions of years of stellar life cycles already present, written into the earliest light Webb could capture. It was as if the universe had already lived before it was born, as if it carried the memory of an older cosmos, hidden inside its first breath. How, one researcher murmured in disbelief, can there be ancestry in a universe barely old enough for infancy? It was not poetry, it was physics unraveling. The presence of heavy elements meant the first stars must have formed immediately after the Big Bang. Massive, hot, short-lived titans burning through their lives in cosmic seconds. These so-called population 3 stars had long been theorized but never seen. If Webb's observations were true, they had come and gone in less than 100 million years, leaving behind galaxies already enriched with the ashes of their dead dot. Teams across the world scrambled to model this accelerated genesis. At Caltech, astrophysicists ran simulations that strained even the most powerful computers, trying to compress the timeline of formation. At the University of Tokyo, cosmologists proposed exotic cooling mechanisms. Perhaps the earliest hydrogen clouds collapsed faster, aided by dark matter, halos, or primordial magnetic fields. Others speculated that dark energy itself behaved differently in those first moments, altering the speed of expansion, warping time in subtle, unmeasured ways. Each theory stretched the boundaries of known physics. None fit perfectly. The paradox only deepened as Webb kept watching. Each new field, each new dataset brought more impossibilities. Some galaxies appeared too bright for their size, suggesting a density of stars that would collapse under their own gravity. Others were too compact, implying that matter was clustering faster than the laws of structure formation allowed. The early universe, instead of a slow unfurling, looked more like a storm, a furious burst of creation racing against entropy itself. Still, the scientists pressed on. They measured, recalibrated, questioned. They turned skepticism into art. But gradually, disbelief gave way to reverence. Because in the quiet logic of the data, there was something profoundly human. The confrontation between expectation and reality, between model and mystery. Every pixel Webb returned was not just a discovery. It was a confession from the cosmos, a reminder that our understanding, however elegant, is always provisional. In Cape Town, a group of astronomers compared the Webb findings with radio data from the Meerkat Array, searching for the faint echo of hydrogen's 21-centimeter line from the same epoch. In Kyoto, theorists resurrected forgotten models from the 1980s, ideas of early cosmic inflation, exotic particles, and variable dark matter. At Harvard, a postdoctoral researcher stared for hours at a folscular image of Jade's GSC 130 and whispered that it looked too peaceful to be that young. Everywhere, the same question returned. What are we really seeing? Because if the galaxies were real, if their spectra were not errors, if their metals were not illusions, then the universe itself had become a historian, preserving memory in light. The photons Webb collected were not just messengers from the past. They were relics of events long buried beneath the expanding fabric of spacetime. Each one had traveled through eons, untouched, unaltered, to deliver its testimony to a civilization that could finally read it. Light had become the oldest record of memory, not carved in stone, but written in the wavelengths of the cosmos. Not stories told by voice, but by color. Every photon a fossil of creation, every spectrum a chronicle of something that should not have been possible. Through Webb's eyes, time itself looked less like a line and more like a loop, a spiral of recurrence, where the past and the present touched. The global scientific race continued, but the tone had changed. It was no longer a scramble to prove the telescope wrong. It was a pilgrimage toward understanding, a collective realization that the cosmos had chosen to reveal something deeper than prediction. And in that revelation was humility, the kind that has always followed our greatest discoveries. The acknowledgement that the universe does not answer to our equations. It invites us to rewrite them, as Webb's golden mirrors drifted in silent precision. Still catching the faint red embers of the first galaxies, humanity listened to light older than its own bones. Those photons, fragile and ancient, crossed the emptiness not to tell us what we expected, but what we had forgotten, that the story of creation is still being written. The data was not lying, it was memory, written in starlight. The paradox did not fade, it grew. Each new image from Webb was not a revelation, but a deepening question. Month after month, as the telescope turned its golden gaze into darker corners of the sky, the data accumulated billions of years of ancient light stitched into a map of the impossible. The first galaxies had been shocking enough, but now the light was coming from even further back, from a time when there should have been no galaxies at all. In the summer of 2023, the Webb team released a new ultra-deep field, the faintest, most distant image ever captured by human eyes. For weeks, it was whispered about before it was shown. Even seasoned cosmologists hesitated to believe what they were seeing. Tiny smudges, smaller than grains of dust, each representing entire galaxies that existed when the universe was only 200 million years old. 200 million, a mere heartbeat after the Big Bang. When the cosmos was still thick with primordial gas, opaque to most wavelengths of light. It was supposed to be a formless time, a void too young, too hot, too dense for structure. And yet, Webb saw order, spirals, disks, luminous clusters, light arranged in patterns that physics had not yet learned to permit. The contradictions piled like stars in a collapsing cloud. According to the CDM model, the cosmological standard of the modern age, galaxies could not have formed so soon. Matter needed time to cool. Gravity needed time to weave. Dark matter halos, the invisible scaffolding upon which galaxies grow, should have taken hundreds of millions more years to coalesce. The expansion of the universe, governed by dark energy, should have stretched time too far for such density. Yet the observations defied all calculation. There were simply too many galaxies, too bright, too massive, too soon. Simulations were rerun. Parameters were tweaked. Still, the universe refused to obey its equations. Even when cosmologists increased star formation rates to their physical limits, the models fell short by factors of hundreds. To match what Webb saw, stars would need to be forming faster than matter could collapse. An acceleration beyond reason. And so, the whispers began. Perhaps the laws of the early universe were not the same as ours. Some speculated that dark matter, the mysterious unseen mass that shapes cosmic architecture, behaved differently then. Maybe it was more interactive, more clumpy, binding ordinary matter faster. Others wondered whether dark energy, that invisible force driving expansion, had once flowed in reverse. A push that was not yet a push. A strange stillness before acceleration began. If so, the very rhythm of the cosmos might have changed between epochs. The early universe could have expanded slower, giving gravity time to sculpt its first masterpieces before being torn apart by cosmic acceleration. The notion was radical, almost heretical, but every mystery in science begins that way. As a whisper against the established order, astronomers like Guido Roberts-Borsani called it a cosmic cliffhanger. A story paused mid-frame, the next scene missing. The universe was unfolding like an unfinished film reel. Its opening sequence burned away, leaving only the middle act, where characters appear fully formed without a prologue. Something had happened in those first 200 million years, something we could not see. A missing chapter between the birth of light and the birth of structure. The cosmos was taunting us with its memory, showing us the aftermath without the cause. In observatories and conference halls, unease crept beneath the awe, because if the standard model of cosmology could not explain this, then everything downstream, from the age of galaxies to the shape of the universe itself, might need rewriting. What if time in the early universe moved differently? What if expansion and matter were entwined in ways we had never imagined? What if our mathematical constants were not constant at all, but evolving, alive in their own way, shifting with the birth of stars? The idea seemed almost poetic, and perhaps too poetic for science. Yet behind closed doors, the most respected theorists admitted they were unsettled. One compared it to watching the script of reality, being edited in real time. Another confessed that the early universe now looked more like an explosion of intelligence than a random unfolding. Not that it implied design, but pattern. Some hidden coherence deeper than equations could express. At Caltech, a group of cosmologists proposed a daring idea that spacetime itself might have experienced an early viscosity, slowing the diffusion of energy and allowing gravity to dominate earlier than expected. At Cambridge, others suggested an unknown field, a fifth force, operating only in the first few 100 million years, accelerating the collapse of gas clouds. In Kyoto, a quiet physicist proposed something stranger still, that what Webb was seeing were not galaxies in our past, but echoes from a previous cycle of the universe, light imprinted from an older cosmos, reborn in this one. It was speculative, even mystical, but in the face of Webb's revelations, no idea felt too far. The paradox reached beyond science. It began to touch something primal, the human need to understand its beginning. For centuries, the Big Bang had been our Genesis story, a singular moment of creation, a clean birth of space and time. But Webb's discoveries made that moment murky, elastic. If galaxies existed so soon, perhaps beginning was the wrong word. Perhaps creation was not a point, but a continuum, a breathing, recursive rhythm, like waves that build themselves. Some scientists, staring at the Webb data late into the night, confessed to a kind of vertigo. The comforting hierarchy of time, first light, then stars, then galaxies, was dissolving. The arrow of creation was bending back upon itself. The universe was behaving like memory, remembering structures before it could logically have built them. In the ghostly red light of galaxies that should not be, humanity saw its reflection, a species built on curiosity, haunted by its own origins, and yet amid the confusion, there was beauty. The same beauty that drove Newton to stare at falling apples, Einstein to chase light beams, and Vera Rubin to follow the whispers of dark matter. It was the beauty of not knowing, the sacred silence before understanding. Because every era of discovery begins with fracture. And from the cracks in certainty, wonder blooms. By late 2024. The Webb telescope had rewritten the first chapter of the universe, not with answers, but with questions. The early cosmos was no longer a calm dawn, it was a storm. Galaxies like embers hurled across the void, too bright, too soon, too many. The models could not catch them. The equations could not cage them. And as Webb drifted in its endless orbit around the L2 point, its mirrors reflecting light from the ancient abyss, one truth became impossible to ignore. Something in the fabric of time had shifted. Something in the birth of everything had gone differently. Something ancient stares back from the dawn, and it should not exist. The deeper Webb stared, the more the universe seemed to stare back, unblinking, ancient, and full of contradictions. And so, the human mind began its oldest ritual, the reweaving of Genesis. When faced with an impossible truth, science does what myth once did. It invents new stories to hold the weight of mystery. Equations become verses. Hypotheses become prayers. And across the quiet halls of Harvard, Caltech, Kyoto, and Cape Town, 1,000 cosmologists set to work, not to prove the universe wrong, but to understand why it refuses to be simple. The first theory to rise from the chaos was one of illusion. They called it the cosmic mirage. Perhaps, some argued, Webb was not seeing impossibly early galaxies at all, but reflections, distortions, magnifications created by gravity itself. Massive clusters of matter, invisible to our eyes, could bend spacetime like glass, warping the light from galaxies far beyond them. In this way, a faint, distant object might appear brighter, older, closer. A trick of cosmic optics, gravity masquerading as creation. It was elegant, even merciful, the kind of explanation that restored order without rewriting physics. And for a moment, the scientific community exhaled. But then came the calculations. The lensing models did not align. The magnification factors were too small, the distribution of mass too scattered. Even accounting for lensing, the galaxies were still too massive. The illusion could not explain away the impossible. The mirage, it seemed, was real. The second theory burned brighter and faster. They called it the early starburst hypothesis. Maybe the first generation of stars, known as Population 3, were far more efficient than imagined, giants of pure hydrogen, living brief, furious lives that seeded the cosmos with heavy elements in record time. If these titans collapsed into supernova within mere millions of years, they could have triggered a chain reaction, waves of star formation cascading across the early universe, birthing galaxies in the blink of cosmic time. For a while, the numbers fit. The theory was thrilling. A vision of the early cosmos, not as a patient architect, but as a wild, ecstatic painter throwing stars into being. But the evidence betrayed it too. Webb's spectral data revealed traces of oxygen, carbon, and silicon, yes, but in quantities that implied multiple generations of stars had already lived and died. There had not been enough time for that. Starbursts alone could not account for such complexity. It was as if the universe had skipped adolescence and awakened fully grown. Then came the whispers of new physics. If observation defies theory, Perhaps the theory itself must bend. What if the laws of matter, of gravity, of light, of time, were different at the beginning? Perhaps constants were not constant, but evolving. Perhaps the Higgs field, the very fabric that gives mass to everything, behaved differently in those early epochs. Some propose that dark energy, the mysterious force accelerating cosmic expansion, once had a different sign, that it compressed before it expanded, tightening the early cosmos into fertile density. Others suggested that the speed of light in the infant universe was not fixed, that photons traveled faster, carrying information across vast distances before the first galaxies even had time to cool. These ideas were intoxicating, dangerous, and profoundly humbling, because to alter the constants is to tamper with the foundation of all physics, to ask whether the cosmos itself learns, adapts, evolves. It would mean that the universe, like life, is not static but self-modifying, that it grows through change, through error, through the rewriting of its own rules. And in that sense, the universe would not merely exist, it would become a fourth camp. Smaller but fierce, turned its gaze to gravity itself. They invoked a controversial idea, modified Newtonian dynamics, or MOND. Perhaps gravity does not behave the same under the extreme densities of the early universe. Maybe its pull was stronger, more efficient, weaving matter together faster than the equations of Einstein or Newton predict. It was not the first time gravity had rebelled against its masters. From the precession of Mercury to the bending of starlight, gravity has always held secrets, whispering truths reluctantly. If MOND, or some new variant of it, were true, then cosmic structure could emerge sooner. Galaxies could bloom where none should yet exist. But MOND had always been a lonely theory, a rebel wandering at the edges of physics. It explained galaxies, but not the cosmic microwave background. It fit the small, but failed the large. To many, it was poetry, beautiful, fragile, and incomplete. And then, there was the most haunting possibility of all, the one that did not seek to fix equations, but to question existence itself. The cyclic, or multiverse model. What if Webb's vision of ancient galaxies was not a glimpse backward, but sideways, across epochs, into echoes of other universes layered beneath our own? In the cyclic view, the cosmos is not a single story, but an endless rhythm, expansion followed by collapse, birth followed by rebirth, each universe leaving traces, ghost light, fossilized structures impressed upon the next. Perhaps what Webb sees are remnants, the luminous handwriting of an older cosmos, carried across the membrane of creation in some speculative cosmologies. Such as Roger Penrose's conformal cyclic universe, this is not metaphor but mathematics. The infinite future of one universe can, through rescaling, become the Big Bang of the next. No beginning, no end, just the pulse of infinity breathing in and out, each cycle forgetting the last, until now. If Webb has indeed glimpsed the fingerprints of a previous cosmos, it would mean the universe is not young, not even ancient, but eternal, a wheel turning without rest. Memory buried in radiation and light. Within the quiet tension of these theories lies a deeper truth, not scientific, but human. Every attempt to explain the unexplainable is also an act of faith. Faith not in gods, but in reason's reach. And yet, the boundary between science and mythology has never been sharp. Both begin with the same ache, the need to make sense of what should not be. The physicist writes in equations what the poet writes in metaphor. Our equations are our myths, one theorist wrote. Dressed in mathematics, They are the stories we tell ourselves about the nature of creation, and every few centuries, the universe rewrites them for us. Perhaps that is the real story Webb has uncovered. Not a flaw in physics, but a revelation of its living nature. The cosmos is not static law. It is process, change, memory. Maybe the universe does evolve, not through random chaos, but through something like learning. Patterns repeating, refining, remembering. Like a musician improvising on an infinite theme. And if that is true, then Webb's vision of ancient galaxies is not an error, but a message. A whisper from before time, saying, everything that has ever existed still echoes here. Every star is a memory of the universe learning itself again. Maybe the first galaxies were not born too early. Maybe we have mistaken the past for the present. Maybe the cosmos is not racing forward through time, but circling back, remembering its own creation in each new burst of light, because perhaps creation is not a beginning. Perhaps it is remembrance, playing itself anew. Maybe the universe does not evolve. Maybe it remembers. The James Webb Space Telescope drifts on 500,000 miles from home, suspended at the quiet balance point of gravity and sunlight. Its mirrors, gilded and geometric, turn like the eyes of a god, scanning eternity one wavelength at a time. Every rotation of its sunshield, every whisper of infrared light that finds its way into its detectors, is a conversation with the beginning. And yet, as Webb continues its vigil, it has become clear that one telescope alone cannot bear the weight of Genesis. The cosmos, vast and sly, demands a chorus of instruments to decode its story. And so humanity builds new eyes. In Europe, the Euclid telescope has begun its long, silent mapping of the dark. While Webb peers deep, Euclid looks wide, charting billions of galaxies to trace the scaffolding of the universe itself. Its mission, to measure the subtle warping of light as it passes through the invisible web of dark matter, and to test the influence of dark energy across cosmic time. If the early universe truly evolved faster, Euclid may see the fingerprints of that haste, patterns in galaxy distribution that betray a different rhythm in the cosmic expansion. It is not a rival to Webb, but a complement, a second movement in a symphony of light. Soon after, NASA's Nancy Grace Roman Space Telescope will join the search. Where Webb sees narrow and deep, Roman will see broad and bright, its vast field of view a panoramic eye on the heavens. It will measure the light of millions of galaxies, their redshifts, their clustering, their subtle motions, all data that may confirm or refute Webb's unsettling hints. Roman will ask a question no less profound than Webb's. Is the universe still accelerating the way we think it is? Or has our understanding of its expansion, the silent heartbeat of spacetime, been built upon sand? On the ground, Earth's most powerful observatories have already turned skyward, their mirrors hungrily chasing Webb's targets. Atop the volcanic peaks of Hawaii, the Keck Observatory stretches its segmented lenses toward the faint red glows that Webb first discovered, testing their spectra, verifying their distances. Each confirmation is a triumph and a tremor. Each data point is a stitch in the widening tapestry of uncertainty. Further south, in the thin air of the Atacama Desert, the ALMA array, 66 radio antennas, linked across miles of salt and silence, listens for the faint whisper of coal dust and molecular gas. It searches for the chemical fingerprints of oxygen, carbon monoxide, and ionized hydrogen in galaxies that should not yet exist. When ALMA detects these molecules, it confirms a chilling truth, that even the earliest galaxies already carried the ashes of older stars. Life's ingredients, it seems, were ancient long before life itself was possible, but the true titans are still being forged. In Chile, under the dry constellations of the southern sky, construction rises for the extremely large telescope, a mirror so vast it could swallow a football field. It will peer with such precision that it could detect the flicker of light from the very first clusters of stars. In the coming decade, it will become Webb's terrestrial counterpart, a ground-based giant tracing the same cosmic dawn through optical and near-infrared light. Together, Webb and the ELT will form a bridge between heaven and earth, between the stillness of orbit and the breath of wind over desert stone. And yet, as the data multiplies, so do the simulations. In cold rooms filled with the hum of processors, humanity builds universes in silicon. Computers now host thousands of virtual cosmoses, each a hypothesis, a variation, a speculative timeline. Astrophysicists adjust the constants of nature like composers tuning an infinite instrument. What if gravity was slightly stronger? What if dark matter clumped more quickly? What if the Higgs field rippled differently in the first second of time? Each digital cosmos evolves, collapses, reforms. And in their comparison to Webb's data, we begin to see not answers, but constraints, boundaries, within which the real universe must have breathed itself into being. Even quantum detectors are joining the search. Instruments so sensitive they can register a single photon born billions of years ago. These machines, cooled to near absolute zero, capture light as if catching snowflakes before they melt. Light that has traveled through expanding space-time, stretched until its wavelength carries the memory of creation itself. To hold such a photon is to hold the past, frozen in motion. As the decade unfolds, the 2025 to 2030 missions will define a new epoch in cosmology. They will cross-examine Webb's claims, refine the timeline of structure, formation, and perhaps decide whether our universe truly began the way we believe it did. But among scientists, there is an unspoken fear that the more precisely we measure, the stranger the universe becomes. Each refinement has so far led to deeper paradox, not clarity. Every telescope that peers further rewrites the prologue. It is as if creation hides behind a moving curtain, retreating just beyond the range of our instruments. Still, humanity persists, because that is what it does best. We are a species that doubts its own knowledge into existence. From Galileo's trembling sketches to Webb's golden lattice, every lens we build is an act of defiance against ignorance, a refusal to accept darkness as final. Even when the data refuses to fit, even when the equations break, even when the cosmos offers only silence, we continue to ask. Because somewhere in that silence lies the echo of the first question ever asked: why? Scientists debate whether the CDM model, our reigning cosmological framework, can survive the coming years. Some argue it will adapt, folding Webb's contradictions into a newer, more elastic form. Others whisper that it is already cracking, that we are witnessing the twilight of a paradigm. But such endings are never truly ends. Every model is a mirror, useful until the light changes. And light, it seems, is changing again. The telescopes will keep watching. The simulations will keep running. The equations will keep bending toward whatever truth the universe will allow. And somewhere beyond the reach of all detectors, in the dim, unseen hours before the first dawn, the cosmos continues its slow and silent creation, indifferent, patient, eternal. Perhaps the question is no longer when the universe began, but whether it ever truly did. For in the depths of the Webb images, in the cold data streaming from silicon and gold. One haunting pattern repeats. The further we look, the more continuity we find. Galaxies forming upon echoes of older ones. Light folded over ancient light. Time remembering itself through repetition. The telescopes will keep reaching for the beginning, but the deeper we look, the less we see beginnings. It drifts there still, silent, patient, unblinking, a golden eye gazing into forever. The James Webb Space Telescope, 500,000 miles from home, orbiting a point of stillness that exists only because of perfect balance. It was built to see the first light, to look back in time, to find the beginning. But as its mirrors unfolded and its instruments opened, what it revealed was not a birth, but a reflection. For every time Webb looked deeper into the cosmos, it found not simplicity, not a singular dawn, but complexity, age folded within age, memory hidden within light. It saw galaxies that should not yet exist, stars born from dust that should not yet have cooled, and in that impossible sight, humanity glimpsed something it had long suspected but never faced. The universe does not unfold like a story told once, from start to end. It loops, it breathes, it remembers. Its time is not a line but a tide, folding upon itself again and again, creation layered like the rings of a tree that never stops growing. And so the telescope, this human-made mirror of gold and mathematics, became something more than an instrument. It became a metaphor, a mirror not just for the stars, but for ourselves. Because when Webb looked too deep, it did not find alien galaxies. It found us, our assumptions, our arrogance, our wonder, reflected back in light older than the Earth itself. Every photon that touched its mirrors had been traveling for 13 billion years, carrying a message written before language existed. And that message, whispered in the faintest red glow, was simple. You do not know the whole story. You never did. Perhaps that is the real revelation. Not that the universe is stranger than we imagined, but that it has always been stranger than we can imagine. We build our equations like temples, our theories like scripture. We trace time backward, searching for a singular genesis, a first cause, a spark, a moment when nothing became everything. But what if there was never such a moment? What if creation is not a beginning, but a process without end? What if every galaxy, every atom, every thought is simply the universe remembering itself again? In Webb's mirror, the cosmos does not look young. It looks eternal, a tapestry already woven long before our species began to ask its first questions. And yet, within that eternity, there is something deeply human. For what is science, if not the act of remembering what we have always known? We have stared into the night since before history, tracing the shapes of gods, myths, and meaning into the darkness. Now, with metal and silicon, we do the same, but with a different language. The constellations have become equations. The myths have become models. But the yearning is the same. Webb's mirror reflects both light and longing. It gathers photons and questions alike, and sends them home as data, numbers that become images, images that become awe. When scientists see those spirals and arcs, they do not just see distant galaxies. They see time itself bending back to greet them. They see evidence that the cosmos is not receding, but conversing. Each new discovery is less an answer and more an invitation to humility, to wonder, to surrender. Maybe time, as we experience it, is not fundamental at all. Maybe it is only a way of perceiving the flow of change. Perhaps the universe has never been old or young, it simply is. Always happening, always present, its beginning still unfolding at the same moment as its end. We imagine the Big Bang as an explosion, but what if it was, and still is, a pulse? A continuous vibration through which everything breathes. A universe not expanding away from its origin, but repeating it endlessly, intimately, everywhere. In this view, Webb's deepest images are not windows into the past, but mirrors into recurrence. Galaxies forming and reforming across epochs. Patterns echoing through time like music played on a cosmic scale. Each star is not a new note, but a familiar one, replayed in another key. Creation as memory, not invention. Light as message, not history. And perhaps that is why, when humanity looked into the abyss did not look empty. It shimmered alive with the memory of everything that ever was. For all our technology, for all our progress, we are still children standing under an ancient sky, trying to name the unnameable. We built a machine to see the first stars, and instead we found our own ignorance, vast, luminous, beautiful. In that moment, science and poetry became the same thing again, both asking, in their own language, what are we looking at? And why does it look back? There is a quiet paradox in all this, that the more we understand, the smaller we become, yet the closer we feel to the infinite. Webb's revelations have not diminished our place in the cosmos. They have deepened it, because what greater privilege is there than to be conscious in a universe that is still learning itself? To be the eyes of the cosmos turned inward, observing its own origin story with awe and confusion. Perhaps consciousness itself is the final mirror, the place where the universe finally sees what it has always been, somewhere beyond the reach of Webb's gaze, beyond the veil of detectable light. Beyond the curvature of space-time, the mystery continues. New galaxies are forming as old ones fade. New stars ignite where supernova have gone cold. And perhaps, somewhere, another civilization is building its own telescope, its own golden mirror, to peer into the darkness and ask the same impossible questions. They too will see light that should not exist. They too will wonder if their beginning was ever truly a beginning. Perhaps the universe was never young. Perhaps we are the young ones, the last to arrive, the first to wonder. Maybe creation was never something that happened once, but something that happens always, everywhere, within and without. And perhaps that is the most humbling revelation of all, that the universe does not evolve, does not age, does not progress. It simply remembers, through stars, through galaxies, through us. Webb was built to find the first light. Instead, it found that there may never have been a first, only light eternal, folding back upon itself like a story retold. In the end, all the equations, all the theories, all the instruments converge into a single truth too large to prove, that to look outward is to look inward, that every photon carries not just the memory of creation, but the promise that creation never stopped. And so the telescope glides on, orbiting the silence, reflecting both the cosmos and our curiosity. Galaxies shimmer across its golden face like memories, like dreams still forming. And somewhere in that ancient light, the universe is still beginning.